Let's study the relationship between the pointer and the array. So File Explorer, let me create another file, exercise2.cpp, iostream, namespace, std, main function. Let me declare an array, integer array A with the 5 elements. Let me initialize it this way. Then let me compile the program from the terminal. G++ minus G option ex2.cpp. Debug start. No, I should have put the breakpoint first. So here breakpoint start. Started. The array A with the 5 elements is used, but it's this line 5 is not executed yet, so the values are meaningless. Step over, then we have array initialized. That go to the debugger console, and then here let's just find the relationship with the array and then pointer. So A is the name of the array, which shows the contents here, but actually the A itself is the same as the address of the first element in the array. So address of the first element. Let me stop the debugger and then see the relationship between A and then address of the first element. So if I do if A equal address of the first element in the array is A0, and then try to say cout true. Then go back to terminal, compile it, and then run it. It is true. So A, name of the array, is the same as the address of the first element. That's a C++ property. So since A is the name of the array and the address of the first element, I should be able to store A into variable P if I define P properly. Since A is address of the first element, I need a pointer to store the address. And then the first element, if I go there, it's integer type. So int address is a proper way of defining it. That. Go back to terminal, compile the program. Now let's start the debug again, and then examine some values there. So step over is true, step over, and the P is not assigned yet, but however, if I do step over, P has this value. So this value is, go back to debug console, address of a first element of array A is this value. So you check the value here and check what is in P. They are the same. So one of the relationship between pointer and array is that name of the array is actually address of the first element in the array. Since address name is array name is address, you can store the array name into pointer. That's the first relationship we find that. And another one is, as I stop the debugger, once a pointer is initialized by the array name, then you can use a pointer as if it is a name of the array. What I mean by that is, suppose I have for loop to display the contents of the array, 5 increment, in cout, I can display the contents using loop this way, blank, and then I can do similarly with the pointer P with this way. So here, let me explain again. if the pointer, in this case p, is initialized by the array name, then you can use the pointer as if that's array name. What I mean by as if array name is if we have the array name, you can have access to the element to use a square bracket index notation. So you can use a p exactly the same way. So p square bracket, a square bracket, you can use either way if you assign pointer appropriately. Go back to the terminal, compile, and then run it. You can see that those two values are printed in parallel. And this is for any array. So if I have a double array D with 5 elements, and then let's initialize 1.1, 2.2, something like this, then the same rules applies. So I can store D into Y. Then since D is the name of the array, Y should be pointer because D is address. And then if you go to that address, you see double type of value. So this is how to define pointer Y, which stores the name of the address. Also, the name of the address is the same as first element in the array. First element in the array address. So that's the same notation. So you can use this way. Name, you can use name of the array, or you can use explicitly the meaning of the name of the array, like that. You can use either way. And then using loop, same thing. You can display the contents of the array using now pointer. So let me compile the program, and run it. Now those values are using this loop. So instead of the array name, pointer is indirectly used.